So what if I told you that your perfectly climate-controlled house, your really cozy winter sweaters, and that, innocent little splash of almond milk in your morning coffee?
Oh, yeah, the almond milk.
Right. What if all of that is actually the exact reason you feel completely exhausted by, like, 2 in the afternoon?
It's so true.
Because you know that feeling. You get a solid 8 hours of sleep, you drink your water, you do everything quote-unquote right, but you still wake up feeling like you are dragging your body through wet concrete.
Absolutely. And society loves to tell you that this is just, well, what happens?
Yeah.
They say, you're getting older, your genetics are catching up to you, and your metabolism is just naturally winding down.
Which basically frames you as this helpless passenger in a declining biological vehicle, right?
It does,
Yeah.
and it's an incredibly pervasive narrative. And frankly, it's designed to make us settle for mediocrity. We are conditioned to view our metabolic rate as this fixed number on a dashboard, like a number that just slowly ticks downward year after year.
Right, like a countdown timer or something.
Exactly. The mainstream message is that you simply have a slow metabolism, and your only recourse is to spend hours agonizing on a treadmill to burn off a single muffin.
Right.
But when we actually look at the clinical research, the reality of human biology is far more dynamic. You aren't helpless at all.
And that is exactly our mission for today. We are doing a deep dive into this really fascinating clinical document we've got called Van, and it completely shatters this myth of the fixed metabolism.
It really does. It's a paradigm shift.
It is. We are going to zoom way, way in today, like leaving the outdated world of basic calorie counting to explore a microscopic universe inside your body. Specifically, we are looking at your cellular powerhouses, the mitochondria, because we are going to uncover a hidden biological override switch that can quite literally turn your body into a heat-generating furnace.
Yeah, and to really grasp how this override switch works, we have to first understand the default setting.
Okay, lay it on us.
So in almost every cell of your human body, you have these microscopic structures called mitochondria. They're your internal power plants.
Right.
And under normal, everyday circumstances, these mitochondria take the food you consume and the oxygen you breathe, and they basically run it through a complex assembly line.
To make energy, right?
Exactly. To convert that raw material into a molecule called adenosine triphosphate, or ATP.
Okay, let's unpack this for a second. ATP. That's essentially the body's energy currency, isn't it?
That is the perfect way to look at it. Whenever you move a bicep, digest an apple, or, even just form a coherent thought.
Even listening to this deep dive right now.
Yes, your body is spending ATP to fund that action. In biology, we call this standard conversion process tightly coupled.
Tightly coupled.
Got it.
Yeah.
It implies a very strict, highly regulated exchange rate. So a specific measured amount of fuel goes into the mitochondria, and a specific measured amount of ATP comes out.
Like a vending machine.
Right. Energy production is directly tied or coupled to fuel consumption.
Okay. I mean, I understand the efficiency of that, but if our bodies are these perfectly balanced, tightly coupled machines designed to make energy flawlessly,
Which they are.
then why on earth do so many of us feel like our engines are constantly sputtering? I mean, if the system is so brilliant, why do I need, 3 cups of coffee just to feel human by midday?
Well, that discrepancy is exactly what brings us to the core of the research. The issue isn't that your machinery is broken.
Okay.
It's that it has gone completely dormant. The mainstream fitness world wants you to believe your baseline calorie burn, your basal metabolic rate, is static.
Right, that fixed number we talked about.
But your metabolic efficiency is highly responsive to environmental signals. You don't necessarily have a slow metabolism. You just have incredibly powerful biological machinery that hasn't received the correct signal to wake up in years.
Wow, which brings us to the discovery that absolutely blew my mind when I was looking through this material.
It's wild, isn't it?
It is, because waking up that machinery involves a specific type of tissue that most of us don't even know we carry around. We are talking about brown adipose tissue, brown fat.
Right. And this is where the paradigm totally shifts. When most people think of body fat, they're thinking of white fat.
The stuff we usually want to get rid of.
Exactly. White adipose tissue is essentially just a storage unit. It's a biological Tupperware container where your body dumps excess calories for later. But brown fat is entirely different. It's not a storage unit, it's a furnace.
Okay, let's slow down here for the listener because the biology of this is wild. Why is it actually brown? What makes it look different from the stubborn white fat around our midsections?
Well, the color is the key to its function. Brown fat is densely packed with mitochondria.
Oh, the power plants.
Right.
Yeah.
And those mitochondria are incredibly rich in iron. So if you look at it under a microscope, that high concentration of iron-rich power plants literally gives the tissue a dark, brownish-red hue.
Oh, that makes sense. Like rust, almost.
Yeah, exactly. It's brown because it is heavily engineered for intense metabolic activity. And inside the mitochondria of this brown fat, we find a very specialized protein called uncoupling protein 1, UCP1.
Uncoupling protein 1. So this is the biological override switch.
Yeah, it is.
But okay, I have to play the skeptic here for a minute because the terminology feels kind of contradictory.
How so?
Well, if we activate this UCP1 and we uncouple or disconnect the food burning process from the creation of ATP, which is our actual usable energy,
Right.
won't I just feel totally exhausted? Like if I unplug the machine that charges my cellular battery, shouldn't I just collapse at my desk?
You know, you would think so, but the body has a brilliant workaround called thermogenesis.
Okay.
What's fascinating here is that when UCP1 is activated, the mitochondria in your brown fat do not stop working. In fact, they work harder.
Really?
Yeah, they furiously burn through the fuel you provide them. But instead of capturing that energy to manufacture ATP, they allow the energy to dissipate entirely as pure heat.
Wait, let me push back on that. Heat is great if I'm shivering in a snowstorm, sure. But heat doesn't power my brain to write an email or, power my legs to walk upstairs.
That's true.
I still need that ATP to function, don't I?
You do. And that's the beauty of this system. You aren't uncoupling all the mitochondria in your body.
Oh, okay.
Yeah, the mitochondria in your muscles, your brain, and your organs are still tightly coupled, humming along, making the ATP you need to live and function.
Ah, I see.
It is only the specialized brown fat that contains the UCP1 override. So your brain is still getting its electricity, but your brown fat is suddenly incinerating calories simply to elevate your core temperature.
Wow.
You drastically increase your baseline metabolic rate because you are burning fuel for the sole purpose of generating heat.
Okay, here's where it gets really interesting because visualizing this abstract cellular biology can be kind of tricky. But let's build on what you just said about the brain getting its electricity.
Okay, let's do it.
If we picture our standard metabolism like a massive, highly efficient hydroelectric dam.
Oh, I like this.
Right. The enormous reservoir of water held back behind the dam represents the food, the calories we consume.
A fantastic visualization. Let's run with that. So in a normal, tightly coupled state, that water is forced strictly through very narrow, specific tunnels.
Mm-hmm.
And as the water rushes through, it spins giant, heavy turbines. The spinning of those turbines generates electricity for the surrounding city. So water equals electricity, food equals ATP.
A perfectly balanced exchange.
Exactly. It's a one-to-one controlled process.
But every massive dam has a contingency plan. Like, what happens if it rains for 2 weeks straight and the reservoir is dangerously overflowing?
Right.
They don't force all that excess water through the turbines and blow up the city's power grid. They open the emergency spillways.
Yes.
So is that what UCP1 is doing? Is it a biological spillway for our cells?
That is precisely what it is. And the visual there is so important. When the dam operators open those massive emergency spillway gates, millions of gallons of water violently rush out.
Just bypassing everything.
Yes. They completely bypass the electricity-generating turbines. The water crashes down into the riverbed below, creating massive kinetic energy, immense friction, and heat.
But no power.
Crucially, yes, all that rushing water generates absolutely zero electricity.
It is pure, unadulterated expenditure. Like, we are wasting energy on purpose.
Exactly.
So in our cells, when we flip the switch on UCP1, we open those emergency spillways. We allow the energy from our food to entirely bypass the cellular turbines that make ATP, preventing that excess energy from being stored as stubborn white fat.
Look at the profound benefit of that mechanism, though. Instead of your body hoarding every single calorie or creating a surplus of ATP that you don't immediately need, your cells aggressively burn through those energy reserves.
It's amazing.
By learning how to consciously open these cellular spillways, you transform your biology from a stagnant storage container into a highly active calorie-burning engine.
Which is incredibly empowering because it means we aren't broken. We just have these spillways bolted shut. So knowing we have these emergency spillways is great, but how do you and I actually convince our bodies to crank them open? I mean, I can't just sit on the couch, meditate, and politely ask my brown fat to burn off my breakfast. I need a trigger.
Right. You need to provide an environmental signal that demands a biological response.
Oh, what is that signal?
Well, the clinical data provides an actionable toolkit for this. It outlines 3 very specific, zero-cost behavioral protocols that anyone can implement within 24 hours to stimulate this mitochondrial uncoupling and revitalize that sluggish machinery.
Oh, awesome. Let's get into the toolkit, because knowing the science is only half the battle.
For sure. The first protocol is arguably the most potent, and it leverages evolutionary biology. It involves deliberate thermal stress,
Okay.
specifically cold exposure. You have to remember that throughout most of human history, a sudden, intense drop in temperature was a lethal threat.
Right, we didn't have heated seats in our cars.
Exactly. So when the temperature receptors on your skin detect rapid, uncomfortable cooling, it acts as an extreme survival trigger.
The body panics.
The brain senses this, initiates a controlled panic, and sends a massive, immediate chemical signal to your brown adipose tissue. It essentially screams, open the cellular spillways, generate heat right now, or we are going to freeze.
So we are deliberately hacking a primitive survival mechanism.
We are.
And the actionable step here is beautifully simple, even if it sounds a little torturous. Tomorrow morning, at the very end of your comfortable, steamy shower, you reach up and turn the dial to the absolute coldest setting possible.
Yes. But the nuance is critical here. It is not just about getting pulled generally.
Okay, what's the trick?
The protocol dictates standing directly under that freezing stream and focusing the water specifically on the back of your neck and your upper shoulders.
Wait, really? Why that specific spot? Why not just blast my chest or my legs?
Because the back of the neck and the upper collarbone area is exactly where adult humans retain the highest concentration of brown fat.
Oh, wow. I had no idea.
Yeah, think about human babies. They can't shiver to keep warm, so they are born with thick pads of brown fat around their necks to protect their core temperature.
That makes total sense.
As adults, we lose a lot of it, but we retain a crucial reserve in that upper back and neck region. So by focusing the freezing water there, you are delivering the thermal stress directly to the specific receptors that control the uncoupling process.
You are knocking directly on the door of the furnace.
Exactly.
So the protocol says you need to stay under that cold water for 1 to 3 minutes. And the hardest part is probably overriding the instinct to tense up and hold your breath, right?
Oh, definitely.
You have to focus on slow, deep, controlled exhalations to manage that initial shock.
The breathing is what keeps you in control.
Yes.
You are basically telling your nervous system, I am not in actual danger, but I need you to heat me up anyway.
I love that. So 1 to 3 minutes of shivering discomfort to turn your body into a literal calorie-burning furnace for the rest of the day. That is an unbelievable return on investment.
It really is.
Okay, now let's look at Protocol 2, which is fasted morning phototherapy and movement. This moves us away from temperature shock and into our circadian biology.
Right. Because your metabolic rate doesn't just operate in a vacuum.
Yeah.
It is inextricably linked to your internal 24-hour clock. This second protocol involves combining natural morning sunlight with light cardiovascular movement, and crucially, doing it in a completely fasted state.
Okay, so the specific action step is this. Within 30 minutes of your feet hitting the floor in the morning, before you eat a single bite of food, you step outside into natural sunlight for a brisk, continuous walk of about 15 to 30 minutes.
That's the one.
But let's dig into the why here.
Yeah.
Why the empty stomach and why outside? Like, why couldn't I just drink a protein shake and hit the elliptical in a dark gym later in the afternoon?
Because you would miss the dual trigger effect.
Okay, break that down.
Let's look at the sunlight first, the phototherapy part. You have a cluster of nerves deep in your brain called the suprachiasmatic nucleus. It's essentially the master clock for your entire biology. When unfiltered optical light, specifically the wavelength of natural morning sun, hits your retinas, it sends a powerful, undeniable signal to that master clock.
So it's literally waking your brain up.
Right. It tells your brain the active daytime phase has officially begun. Boot up all the metabolic systems.
So the light flips the master power switch in the brain.
Exactly. But then you combine that master switch with a fasted movement. Because you haven't eaten since the night before, your bloodstream is entirely clear of fresh fuel.
Right. No toast or oatmeal in the system yet.
There is no circulating glucose from a morning bagel, but you are demanding energy by walking briskly. The body has no choice but to look internally.
Oh, I see.
You force it to tap into stored reserves. So you are simultaneously telling the brain, wake up, it's daytime, while telling the mitochondria, we need energy right now, burn the reserves.
It makes perfect evolutionary sense. It's the biological equivalent of waking up in a cave and realizing you have to go hunt for your breakfast.
That's exactly what it is.
Your body has to be sharp, warm, and utilizing its own fat stores to get you moving.
Okay, so we've done the cold shower, we've done the fasted walk in the sun. Protocol 3 is where things get really interesting, especially for anyone who loves their morning beverage.
Oh, yeah.
Protocol 3 is polyphenol thermal triggering.
This is a fascinating application of hormesis, which is the idea that a tiny dose of a biological stressor actually makes the body stronger and more active.
Right.
Polyphenols are naturally occurring chemical compounds found in certain plants. The plants produce them as a defense mechanism. But when humans ingest them in specific quantities, they act as a gentle chemical stressor that actively upregulates the expression of those UCP1 uncoupling proteins in our brown fat.
And the best part is we don't even need expensive supplements to pull this off. The research highlights 2 highly accessible sources. You are looking for chlorogenic acid, or a compound called epiglycoglycan gallate, which is often just abbreviated as EGCG. Exactly. And the actionable step here is incredibly straightforward. Mid-morning, you consume 1 large cup of high-quality organic black coffee, which is loaded with chlorogenic acid.
Sure.
Or if you don't like coffee, you brew a cup of pure green tea, which provides the EGCG.
Okay, I know half of our listeners just groaned because they are picturing their favorite vanilla oat milk latte, and we have to deliver some tough news.
We do.
The research is rigid on this point. There is a strict rule. The beverage must be perfectly plain, absolutely no sugar, no dairy milk, no oat milk, no honey, not even 0-calorie artificial sweeteners.
Nothing.
And it must be consumed on an entirely empty stomach. So why are we so militant about a tiny splash of milk? Like, does a tablespoon of almond milk really ruin the biological magic?
It completely derails it, actually.
Yeah.
And we have to look at the mechanism of insulin to understand why.
Okay, let's hear it.
Insulin is fundamentally a storage hormone. Its entire job is to patrol the bloodstream, look for incoming energy, and pack it away into storage cells.
Right.
The moment you introduce any calories, especially carbohydrates or sugars from milk or syrups, your pancreas spikes your insulin levels to manage that incoming energy.
So if I drink a latte, my body is flooded with a hormone whose only directive is store everything.
Precisely. And insulin actively suppresses fat burning and thermogenesis.
Oh, wow.
Think back to our dam metaphor. Insulin is the dam operator slamming the emergency spillway gates shut because it thinks it needs to hoard the water.
Oh, that paints a perfect picture.
Yeah. So when you consume the coffee or green tea entirely black on an empty stomach, you deliver that pure bitter chemical signal, the polyphenols, straight to your cellular receptors.
Without the insulin blocking it.
Exactly. You instruct them to enhance heat production and open the spillways, all without triggering a single drop of insulin that would contradict the order.
So insulin and the UCP1 spillway are biologically incompatible. You either store the energy or you waste it as heat. You can't do both.
That is the crucial takeaway. You have to keep insulin completely flat if you want those polyphenols to uncouple your mitochondria.
Well, let's zoom out here for a second because we have covered some heavy biological ground today.
We really have.
We started with the myth of the fixed, declining metabolism. We looked under the microscope at brown adipose tissue and the iron-rich mitochondria that power it. We conceptualized uncoupling protein 1 as the emergency spillways of a massive cellular dam, letting energy rush out as pure heat instead of being stored.
Right.
And we walked through an incredibly practical, zero-cost toolkit: the targeted cold water shock, the fasted morning walk in the sunlight to set the circadian clock, and the plain bitter green tea or black coffee to chemically trigger the uncoupling.
It's quite the toolkit.
So when you step back and look at all this research, what does this all mean? What's the ultimate conclusion?
Well, the overarching philosophy is that your biology is an incredibly adaptive, highly responsive ecosystem. You are not a victim of your age or your genetics.
That's so important to hear.
It is. Your body possesses dormant, highly advanced metabolic machinery that is simply waiting for the correct environmental signals to turn on. The lethargy and the sluggishness of modern living are not life sentences. They are just symptoms of an understimulated system.
It is incredibly hopeful. It shifts the power dynamic completely back to you, the listener. You hold the keys to your own metabolic engine.
Exactly.
And the tools required to start that engine aren't thousands of dollars in experimental therapies. The tools are brief exposure to freezing water. The tools are morning sunlight hitting your eyes. The tools are a bitter cup of plain leaves steeped in hot water.
It's beautiful in its simplicity.
It is. It's profound that the most sophisticated cellular biology responds best to the most ancient elemental triggers in nature.
And, consider the alternative. We live in an era where we seek highly complex synthetic solutions to metabolic problems that are entirely caused by a lack of basic evolutionary stimuli.
Which actually leads me to a really profound thought to end on. Think about everything we just discussed. If brief, intense exposure to natural stressors, like a blast of freezing water on your neck, the bitter defensive compounds in a plain plant, and the physical demand of moving on an empty stomach under the morning sun.
Right.
If these are the precise signals that wake up our metabolism and crank open those cellular spillways, it really makes you scrutinize the way we live today.
Oh, absolutely. The modern environment is practically engineered to eliminate all of those things.
Exactly. We live these hyper-comfortable, completely climate-controlled, artificially lit lives. We never let ourselves get too cold. We rarely force ourselves to move before we've eaten a massive meal.
And we pour sugar and milk into everything bitter to mask the taste.
Yes. So what if all this relentless comfort is accidentally acting as a massive hibernation signal to our bodies?
That makes a lot of sense.
What if our pursuit of perfectly controlled comfort is exactly what is locking our spillways shut and trapping us in a perpetual state of sluggishness?
That's a very compelling conclusion. The absolute absence of environmental stress has essentially become the biological signal for dormancy.
And that dormancy is exactly what causes that feeling of moving through wet concrete that we talked about at the very beginning of the deep dive.
Yeah, full circle.
So, as you go about your day today, I want you to look around your environment and ponder this question. What comfortable, luxurious part of your daily routine might actually be putting your metabolism to sleep? And more importantly, which of these ancient zero-cost signals are you going to use tomorrow morning to wake it back up?